we are going to continue our talk of solving equations with variables on both sides. We're going to continue to add a little bit to it. The first three problems I presented you are going to be review. I will do the first one, and then I'm going to ask you to pause the video. Remember, my teacher made me use letters to the left, so I would subtract 4x, subtract 4x, drop down the 8, minus 9x equals negative 1. Now I am just left with a two-step equation. I'm going to isolate the variable by moving 8 to that side. I would subtract 8 from both sides, drop down the negative 9x, being very careful not to forget the negative sign. That equals negative 9. Divide, x would equal positive 1. Please pause the video. Do the next two by yourself. When they are completed, start the video again. Okay, if you have those two problems done, you may unpause the video. Take a minute, compare your answers to mine. Do we have the same answers? If not, pause the video again. Determine where you and I have different answers. Next, we're going to solve, but we're going to look at the three different types of solution. There's going to be one solution, no solutions, or infinitely many. This is going to be just an introduction to system of a linear that we will do in a month or two. Remember last year when you would graph, you would often have the equation y equaled mx plus b. This would be your starting point, the y-intercept on a graph. That would be your unit rate, your rate of change. If we look at these equations, that's exactly what this is. This is your mx plus b for one equation. We're setting it equal to the mx plus b of the second equation. So you have one straight line set equal to another straight line. We're going to solve this just like we did up there. I will add 2x, add 2x. I get negative x plus 1 equals negative 1. Now I will subtract 1 from both sides. Negative x equals negative 2. Be very careful with that negative that you remember to drop it down. That's a negative 1x, so I will divide by negative 1. And x equals positive 2. Because I got an answer, a digit, a number, I know that x equals 2. If I put 2 into this math problem for x and 2 into that math problem for x, it should work. So I'm going to cover it up a minute, and I will substitute 2 into the equation for each x and solve. Using order of operations, negative 3 times 2, negative 6. Negative 2 times 2, negative 4. I will simplify on the left side. I will simplify on the right. 5 equals 5. So when we put we put 2 in for x, this side of the equation equaled that side. Awesome. Now, in the future, we're going to be solving math problems like that, and we would be about halfway done. What you would do next is you would pick either side of the equation. It does not matter if you use the left-hand side or the right-hand side. I'm going to pick the right-hand side. I'm going to substitute 2 into this equation and solve for y. Again, You could substitute on the other side. You would get the same answer. I know we know what this is. I would get -5. When I apply these two lines to the graph, they are going to have one solution where x is 2 and y is -5. I'll review how to graph if you want to watch. I'm going to graph the left-hand side. I start at +1 and I realize the lines came in horribly. My rate of change is -3, so 1, 2, 3, right 1. 1, 2, 3, right 1. I will do my best to draw a straight line. I now am going to graph this side of the equation. Starting point of -1 on the y-intercept. I have a rate of change of -2, so I will move down 1, 2, right 1. 1, 2, right 1. 1, 2, right 1. Now I can tell that my picture is off. These were supposed to meet and cross at the point 2, -5. It may have worked if I had darker grid lines. I would like you to take the next few seconds, solve this one, peek at the screen once in a while. I will be solving it silently. Let's make sure we're doing the same work. Oh, I didn't get very far. Once I started moving the variables from one side of the equal sign to the other, they canceled them out. I ended up with 1/2 x minus 1/2 x on both sides. That gets me 0x. My question to you, is 3 equal to -2? Is that true or false? Will that ever be true? Will that always be false? I think of money. $3 is not the same as owing someone $2. So this is a false statement. Therefore, there will never be a solution. They will never cross on a graph. If I graph the first equation, doing the best I can to see these awful grid lines, I would start at 3, then I move up 1, right 2, up 1, right 2, and I should have a line that looks like this if I connect it correctly. On this one, I'm going to start at -2, my y-intercept, rise over run, so I'll move up 1, right 2, up 1, right 2. Oh, what do you notice? What kind of lines will never ever cross? Parallel lines. Parallel lines will have no solution. The solution is where the two lines cross. Now we're going to do an example of infinitely many solutions. I will subtract 4/3 x here, subtract 4/3 x there. Oh, same sort of situation. My variables go away. But then I am left with -2 equals -2. Again, is that true? Is that false? That is definitely true. -2 will always equal -2. So think to yourself a minute, what do you predict this graph will look like? When you get an answer of a digit, it's going to cross in one spot. When you get two numbers that are never ever going to equal, it's because the two lines are parallel. There is no solution. They have absolutely nothing in common. Now we have two numbers that are identical. They will always equal each other. Let's see what the graph looks like. Again, I'm going to start at the y-intercept of -2. Then I will go 1, 2, 3, 4, up 1, 2, 3, doing the best I can with these lines. So that will be that line. On top of it, I will use the green and graph this equation. Oh, do that, then I would go, oh, what I'm noticing is when I graph, they fall right on top of each other. Well, if I had taken a minute and looked at the original math problem, I would have noticed this side of the equal sign is identical to this side of the equal sign. Therefore, if the two sides are equal, infinitely many, I could put any number in for x and I would always get the same answer. We are going to now begin to combine like terms on both sides and then solve. When I approach these math problems, sometimes I take a sticky note or I cover up one side of the equal sign first. Remember, I used to caterpillar, so if I very carefully with this small print, caterpillar, what I see on the left-hand side of the equal sign, bubbles I can combine, I end with 18x plus 6. I didn't take the opposite of anything. I'm just combining like terms. Move my sticky note over for a moment. Complete the caterpillar if you would like. Combine any like terms. I'm just going to peek. I would have negative 10x minus 10. Here's my x's, my integers. Great. Now I am ready to solve like we were doing the other day. I will add 10x, add 10x, negative 8x plus 6 equals negative 10. Be very careful you keep the negative sign. Now I have a two-step equation. We've been practicing that a bit. Divide, I would get x equals 2. If x equals 2, will I have one solution, no solution, or infinitely many? I would have one solution. They will cross somewhere on a graph where x equals 2. Later, we're going to solve for the y's. Once again, I would like you to pause the video, complete the next two problems I covered. When those are completed, please resume the video. Once you have finished solving, compare your answers to mine. For the middle one, I had x equaled 13. Because x equaled an integer, I know that I will have one solution. When I solved the second one, x equaled negative 1.5, written as a decimal or a fraction. X is now a rational number, therefore I have one solution. Pause the video. Take a moment to check your answers next to mine. Where are we different if you got a different answer? Pause the video, please. Continuing to the next page. This is where we're going to distribute and solve. I'm going to do the middle problem for you first, and then I'll ask you to pause and do the next two. On this one, like we were doing the other day, you need to distribute first. Anytime there is a number written next to parentheses, that means multiplication. I would have 16 minus 4x equals 6x plus 6. Oh, we're back to variables on both sides. Divide the problem in half if you would like. I will subtract 6x from both sides, making sure to line up my like terms. Drop down the 16. Negative 4 minus 6 more is negative 10x equals 6. We are now down to a standard two-step equation, so I would subtract 16 from both sides, negative 10x equals negative 10. Divide by negative 10, x would equal negative 1. If x is negative 1, how many solutions do we have? We have one solution. Somewhere on a graph where x is negative 1, the two lines would cross. At this point, again, I want you to stop, pause the video, solve the problem to the left, and the problem to the right. Will compare answers in a moment. Please pause the video. Thank you for pausing the video. I began working on the problem on the left, and then I noticed something. After I had distributed the 4, I ended up with 12 plus 8x, and I noticed that the left-hand side of the equal sign and the right-hand side of the equal sign were identical. If they're identical and we were to graph them, the two lines would land right on top of each other. So therefore, I really know this has infinitely many solutions. They're really the same line, but I can prove it mathematically. If I subtract 8x, subtract 8x, oh, the variables are gone. I am left with 12 equals 12. That is very true. When it is true, that means they are the identical line. I could carry on and say, well, I'll subtract 12 from both sides. I get 0. Oh, does 0 equal 0? Yes, forever and ever. Therefore, it is still true with infinitely many solutions. The math problem on the right, I very carefully solved, and I ended with x equals 5, 6. If you gave me the decimal, I am fine with that. Because I got a number for x, it means one solution. We're going to continue to kick it up a little bit here. Now we're going to distribute, then combine like terms, and then solve. I will complete the problem on the left, and then I'm going to ask you to complete the problem on the right. First, I'm going to cover this side up. I see there's numerous things going on. First, I will distribute. So I have 3x minus 24 minus 5. Being very careful with the negative signs. Combine these two like terms. 3x minus 24. Nope, 29, my apologies. When I combine those, I would get 29. I am not with any terms that are the same. I can go no further. I will then cover up the other side. Distribute 9x, excuse me, my brain got ahead of me. 9x plus 18 plus 1. Combining my two like terms here. If they're in the bubbles, I would end with 9x plus 19. I don't have any more like terms on that side of the equal sign. Now I'm at the two-step equation process. Minus 9x, negative 6x, being very careful again with my negative signs. Add 29 to both sides. I get 48. Divide by negative 6, x equals negative 8. Would that be one solution, no solutions, or infinitely many? It would be 1. Again, I'm going to ask that you pause the video, do the next two problems. Please pause. Thank you for pausing the video. When I did the middle problem, I ended with x equals 1. Therefore, there is one solution somewhere on a graph. They're going to cross where x equals 1. As I began to solve combined like terms, I used my sticky note. This was quite a problem to start with, but then I realized when I started to isolate the variables, I ended with two numbers that will always be false. They will never equal each other. Therefore, they're parallel lines. There will never be a solution. They will never cross. This has been a very long lesson. I appreciate your patience. Please pause the video one more time. Solve the next three. When you are done solving these three, let's compare answers. Please pause the video. Thank you for pausing the video. For the first one, I had to really move my camera. I did a lot of fraction work to end up with x equals 2 2/3. If you gave me 2.7, that would be marvelous. Also rounding to the nearest 10. I started the second problem and then I decided to stop because I was like, wait, what's going on? We haven't really done too many like this before where I have variables on both sides, but this is part of a fraction. The variable is. There's two ways to think about it. We know when the variable is part of the fraction, it is a division problem. So for me to undo that, I can get rid of it by multiplying by the reciprocal, and I would cross those off. Therefore, now the right-hand side of the equal sign equals x. If I multiply all of this by 6, I must do the same thing over here. Now I need to distribute, so I would end with 9x minus 6. Oh, believe it or not, we kind of have a two-step equation, so I'm going to subtract 9x from both sides. Negative 6 equals negative 8x. Divide by negative 8. Well, that would be positive 3/4. Is this the only way you could have solved that math problem? Absolutely not. When I give you x over 6, that is really the same as saying 1/6 times x. If I put that here, I could move letters to the left, numbers to the right. We would have come up with the same solution. This definitely was a challenge problem. Okay, on the third one, I did lots of work. I distributed, combined like terms on the right, got to a two-step equation, solved, and I ended at -2. Great job, you guys. That was a big lesson.